So this is how I solved problem number 12 for homework 13. Up here is the original problem, but I went ahead and rewrote this here to account for the functions that we have here. So the first step is to go ahead and find the Laplace of this. So the Laplace would be s squared y minus s times 0 minus 0. That's going to go ahead and account for this y double prime here. And we're going to go ahead and say plus y to account for this y over here. And that, of course, is going to equal e raised to the negative 2 pi s times 1 over s squared plus 1. And that is because when you find the Laplace, it's the integration of e raised to the negative s to the t. So our next step is we can solve for y over here. And big Y is going to equal e to the negative 2 pi times s multiplied by 1 over s plus 1 squared. So now that we have this, we need to find the inverse Laplace of that. So the inverse Laplace of 1 over s squared plus 1 squared, that's going to equal sine squared t, or sine t times sine t. Now that we know that, now we can find our integration, and when we plug into our integration, of course, it's always going to be from 0 to t, but now we're going to have sine of t minus z, sine z dz, of course, to account for the composition. We can further that, and that gives us 1. That's going to give us 1. It's going to give us 1/2 the integration from 0 to t of cosine t minus 2z minus cosine of t dz, because we substituted, and now we can get rid of the integration symbol, and we have 1/2 sine of t minus 2z over negative 2 from t to 0, and we still have our cosine of t multiplied by t on the outside. Further simplification gives us 1 over 4 negative sine t minus sine t minus 1/2 t cosine of t. And of course, you can see how that's going to give us 1/2 sine t minus t cosine t. And go ahead and applying another Laplace inverse to go ahead and finish up the problem. If you look at your table, you can see that the Laplace inverse of y of t equals 1/2 sine of t minus 2 pi minus t minus 2 pi again, multiplied by cosine of t minus 2 pi, and then we have our ut of 2 pi. And of course, all of those are because of the transformation that we have at the beginning from the original graph. And that is the solution to problem number 12.